All right, it's about time to start. Hello, everyone. Good morning and good afternoon, whatever, or good evening, whatever time zone you're in. I sincerely welcome you to Illuminate, the Lumenci webinar, our platform where technical personnel explore the latest innovation in emerging technology. I am Dr. Bernard.ku, head of the Telecom Wireless and Networking Group in Lumenci. Today, I have the pleasure with Babbalpreet Kaur, one of our expertise in this domain. We will have a wonderful story to share with you. We will talk about the future of cellular network, from 4G, 5G, all the way to 6G. Everybody probably should have understand the importance of cellular network today. They change all our life. In case you have a teenager or have a young adult son or daughter, you can ask them one question. What is the first thing you saw in the morning? What's the last thing you saw in the evening? They both will answer you, my cell phone, right? That is including me too. So today we'll talk about this technology and how it will impact our life, taking from 5G all the way to 6G. We will have 30 minutes of masterclass, followed by 10 minutes of question and answer. Please feel free to post us any question in the chat box or ask us in live so that we will take care of it at the end of our talk. Next slide, please. All right, this shows us our agenda. So we start off with evolution of the mobile network from 1G all the way to 6G. The key takeaway is what we learned from this evolution. What are the two key takeaways that allow us to build the content? We all know content is the king. What are the future killer applications that will further enhance our life? We want to show you some example of it. And then Babbal will talk about all the enabling technology behind this evolution, including the antenna technology, massive MIMO, beamforming, software-defined network function virtualization that will constitute the 5G network slicing. She will also give you a big picture of the future 6G network. Bear in mind that the 6G network is still underdefined in the standard body, 3GPP. So we will give you a good picture of what we perceive 6G network will be. We also will compare 6G with 5G. What's the game to us as a normal consumer? We will then switch on to talk about the challenge of the 6G network. Being a new generation mobile network, it will never be without challenge or hurdle to make it happen. It takes roughly around 10 years to build a new generation mobile network. So we need to understand that what go ahead. What are the new things or technology that they will be incorporated so that we can all well prepare as a consumer and also as a technology developer and also our company, Lumenci. We will then talk about our role of Lumenci in managing this emerging technology, how we equip and how we are well positioned to meet the future challenge. And then we'll come to Q&A section. Next slide, please. All right, this one shows you a good picture from the 1G all the way to 5G. Not only the earlier generation of the cell phone, just like a water bottle, no one wants to carry, but it is very, very slow in terms of data throughput. You can compare the weight, more or less like 24 kilobit per second, compared with 5G all the way up to 10 gigabit per second, right? And we see that in 4G, that is some changes. In 1G and 2G, they just carry the voice. In 3G, along with the iPhone at that time, they can also serve a web browser. They can carry also data. Bear in mind that up to 3G, there is two domains. One is a circuit switch domain, carry the voice. The other is a packet domain, carry the data. so that we can do testing, short mesh SMS service like that. In 4G, there will be a fundamental change in the medium carry the traffic. In 4G, we will have an all IP mobile network. Both the voice and also the data will be carried on the IP packet domain because of its connectedness nature. Bigger throughput, bigger bandwidth, so that we can have more data in a bigger bandwidth, more or less like a bigger pipe to carry the media. In 5G, we'll see a lot of new things coming too, including the new C-band, some new spectrum, millimeter wave, MIMO technology that Babba will talk about that. The most important is it is very, very fast, up to 40 gigabit per second, up to 10 gigabit per second. Let's go to the next slide. All right, so this gives you a full picture of the evolution. We will focus on 6G now. 6G will be have not yet been defined yet, as we shared with you before, but it's rumored to carry all the way to 1 terabit per second. Very, 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 very big bandwidth, right? So you focus on the right-hand side, we expect to have new spectrum. We will see disrupting technology that will change our life that we need to adapt and accept to. We will see more virtualization of service, including the monolithic RAM area, the radio access network area. At this time, this layer is still closed or proprietary. We also see a lot of green devices, which is all energy efficient. And without any doubt, AI, artificial intelligence agent, will be everywhere, connecting every device together. Next slide, please. All right, throughout the evolution, we will have two takeaways. Hope all of you will understand that. The left-hand side shows you the speed. Speed in terms of upload speed and also the download speed. Of course, we are more concerned with download speed. For example, when we download a high-quality Netflix movie, you can see in 1G network, it's just 2.4 kilobit per second. But in 5G, it is all the way up to 10 gigabit per second. Very, very fast compared with the first generation, right? So that's a key takeaway. That's all. This is download speed, but that can also apply to the increase in the upload speed. All right, so we'll continue to see the speed going up all the way to 1 terabit per second in 6G as we foresee. The other key factor or takeaway we need to focus on is the latency. Latency is the measure of network delay, i.e., how long it takes the data to reach the destination. More or less like a round trip, right? So that's important. That tells you how responsive your network is. You can see that in 1G or early on, it's about 1 second. But in 5G, it's down the way to less than 1 millisecond or 5 milliseconds. In 6G, it will be approaching 1 millisecond. Why that matter? Because if the network is robust and highly responsive, we can do a lot of time-critical application. We will see in a couple of slides. Next slide, please. So this one, everybody know that it is a surgery table. The only live person in this picture is the patient lying on the surgical bed. I guess no one really would like to be that patient, right? But sometimes you might not have choice because you have a urgency, for example, open heart surgery, how people will airlift you to the nearby hospital. You might not have choice. So you might be operated by remote surgeon. That means you are in a line in the hospital with a Da Vinci machine, and the surgeon will be probably 100 miles away and operate on you. You might not have choice, but that will save your life. In the future, robotic surgeon will take over for minor surgery. That is going to happen. That's all because of these two takeaways. High, ultra fast upload and download speed to give the surgeon or the robot a key picture of what's going on when they do the open heart surgery, for example. And also whenever an action taken by the Da Vinci machine, the network is so robust to let it happen without any latency or delay at all. Next slide, please. Another one everybody will see is coming, driverless car. It will be everywhere in 6G or future. Apple working on that, Google working on that, lots of vendors working on that. So how that will make it happen? Driverless car, no people inside the car. How can the car operate? It must be go through a lot of data input and also output. We'll just take two examples. For example, the V2V vehicle communication. For example, given a brand of car like Tesla, they can advertise this V2V car among themselves. Like the first Tesla car in the front, they will send some traffic condition, such as roadblock, traffic condition, traffic accident, or even traffic cop ahead. And this vehicle, being the first vehicle on the highway, it will send the signal to all the V2V network, all the Tesla car in this network, so that the other car following it can prepare, right? That's important to increase brand loyalty and increase revenue. Another one you can see that is between the V2V, V2P, P stands for pedestrian, the people walking on the street. Let's say, for example, when you are walking your dog, your pet, the pet run loose, right? When the pet run loose, you will catch it, but the pet usually run faster than you, right? So if the pet is enabled with RFID tag, it will be able to communicate to all the car nearby, taking assumption that the car usually run faster than the person, right? So a car will have nearby car running around, will have a much better chance to spot the pet. And once it spot the pet, it will stop and inform it to the owner. And hey, we got hold of your pet. Don't worry, we have it safe in a safe place. Come here to get it when you are able to. Other things going on, like the V2I, vehicle to infrastructure, such as a city, right? The home, smart city, smart home, that all happen. For example, the city of the city of Austin can implement smart city. When they see light traffic in 6th Street, for example, they can dim the light, right? They save a lot of money. They also controlling, sensing the pollution and trying to direct the traffic from one congested area to another area. So a lot of things can go on. A lot of things can go on. Other thing is the work vehicle to network infrastructure. How about supporting not only the Tesla brand, how about all the brand able to run in 5G or even the 6G? So for sure, those killer applications will enrich our life and make our life more comfortable and easy. Now we will turn to the next slide that Bubble will take over and talk about the technology enabler.
Thank you very much, Bernie. So if we start from the basic, the first thing to know about antenna is that it contains radiating elements, so which radiate electromagnetic waves in particular directions, right? So if we like the radiating more directive pointing in a particular directions, then we put multiple radiating elements next to each other and feed them same or different signals as per the requirements. So when we put two radiating elements next to each other, we will get twice of the energy. And when we will put 4 radiating elements next to each other, we will get 4 times of the energy. So if we want to radiate the beam in multiple directions to multiple users, we will need to use multiple signals. Those would be of different phase and amplitudes to cause the constructive interference in particular direction. We can also use multiple antennas for spatial multiplexing. That means we send multiple beams at the same time. So it could be for the same user or to be the different users, as you can see on the screen. So when we have too many radiating elements, let's say 64 or more than that in horizontal or vertical polarization, it makes messy MIMO. That is multiple input, multiple output. So in this case, the transmitter simultaneously sends different users using the same time and frequency resources, thereby increasing the network capacity. Next slide, please. Right. So where 4G was about connecting people to internet, 5G is way beyond just connecting people to data, but connecting everything to every device. So it is wireless interconnection for every person to machine on the planet. So 5G supports multiple service verticals, which are very, very different in terms of expectations, like Bernie already mentioned, and those needs different network resources. To support these different service verticals, we need to logically divide our network, which is actually implemented over a single physical network. So how do we really do it? So the answer is network slicing. So we have basically three user scenarios in this case that you can see on the screen. First one is, we call it EMBB, that is enhanced mobile broadband. So if we are going to connect everyone to everything, like we see in the V2X communication, we need more data and streaming bandwidth. So I think we can all relate to this. For example, if we are live streaming this talk and we are on continuous video calls at work, so the primary measure of EMBB is how many billions of information we can stream every second. So if we talk about just a theoretical concept, so we need 20 Gbps of downlink and 10 Gbps of uplink speed. Let's talk about the next case scenario, that is URLCC, that is ultra reliable low latency communication. Let's say if our Netflix goes down just for a short amount of time, right? It is a huge inconvenience for us, for sure. So, but if you want to run the mission critical infrastructure and autonomous vehicles on the network, then those networks must respond very, very quickly and be much more reliable than they are today, right? As Bunny already explained, like if there are different vehicles running on a road, so the network would be really, really fast. The third scenario we will talk about is MMTC, that is massive machine type communication. So this is about connecting billion of smart IoT, Internet of Things devices to the cellular network. For example, most of our devices at home, smart devices, so like thermostat or the automated lighting, they connect over a Wi-Fi or Bluetooth. They are only useful as long as we are at home network, right? So the goal of MMTC is to make any device work anywhere your cell phone can go, and you can control all the smart phone devices outside from your home too. So these are the different service lines majorly we have in today's scenario, and those can implemented by using the 5G slicing. Next slide, please. Thank you. So this slide basically shows the advancements of 6G over 5G. So let's say you want to download HD movies, let's say size of 21 TB. So if you're using the 5G, it may take up to 5 hours, but you'll be able to download the same data just in 18 seconds with 6G connectivity. So this is how impactful 6G going to be. Next slide, please. Right. So this figure depicts the 6G network architecture. So in 6G communication, it would provide everywhere with the help of drones, satellites. You'll see radio remote heads, visible light communication, base station, and different 6G network equipments mounted on moving things. As we already explained, that 6G will be revolutionary in healthcare system, which eliminate time and space barriers through remote surgeries, that there may not be need to doctor to be present in the operation theater anymore. So as most of the mobile, there is one case we have, as most of the mobile traffic is generated indoors, and moreover, cellular network have never really been designed to target the indoor coverage efficiently. So 6G also covered these challenges using femtocells and all the distributed antenna systems. Another benefit of the 6G is it also uses visible light, so which leverages benefits of LEDs such as illumination as well as the high-speed data communication at the same time. And the visible light does not produce any electromagnetic radiation, so it is also susceptible to external EM interference. So this is how the 6G is going to change the world. Over to you, Bunny.
Thank you, Babu. Yes, Babu talked about the how. The how is how to make 6G happen. We all know the latest and greatest technology enabler. Babu talked about beamforming, also talked about 5G network slicing. But there were a lot of other software components behind it to make it happen. So let's take 5G network slicing example. It is enabled by software-defined network and also network function virtualization. Those are software technology. So you can see that when we are dealing with the ethos and mobile network change, we need to understand that the underlying technology, sometimes not in this domain, but in other domain, like software domain and also semiconductor domain. Next slide, please. Thank you, Babu. All right, so we will switch gear to talk about the challenge of 6G network. As I mentioned before, there will be a lot of AI or artificial intelligence agent in all the devices connected together. I'm not talking about connecting locally. I'm talking about connected globally, right? Every device will not be an island. They'll be all connected. Let's say, for example, we take the V2V car or the V2I network we talked about before when we talk about the killer application. Let's take the busiest city, New York City, as example. There will be millions, if not millions, there will be thousands of cars going in and out the great New York City in a day. Imagine they are all driverless cars, right? Let's try to zoom into a single junction. How will each car make way to each other in case there's no signal light giving a turn like that? How do you want the other pedestrian, to watch out for the traffic? So there will be a lot of software agents working on they're running enabled by ML, machine learning, deep learning algorithm to run those scenarios and also forecast the best available choice for the devices. Maybe potential, maybe devices like 5G car or 6G car in the future. So you can see that there are lots of AI-enabled applications running on, enable every environment to work, including hospital, including manufacturing, including school, campus, like that too. So we will see this coming. Next slide, please. All right, so going through from a network concept to an actual deployment, that takes time. In a single generation mobile network, normally it takes an average of 10 years to get it mature. Now we're in 2022, so we're working on release 18, which is focused on the 5G Advanced. We are in the 5G now, but the standard body have already started work in 5G Advanced. Not a lot to change, but probably will be some change in the spectrum handling, the radio resource area like that. But 6G will not take place until release 21. If you see the timeline, it's about 2027. So it will take maybe a minimum of 5 years to make it happen. Every vendor, every operator come to the same table, agree or get a consensus of what the future for 6G network would look like. From what we observed, we did not see a lot of change in the core network, but we will see a lot of change in the radio access network side, including the antenna technology and how to best handle the radio resources. It will take time. It will take agreement. So it will be a good challenge. It will be a good challenge for all the parties involved and agree on the same table. But nevertheless, it will happen, just like all the previous generation of network. But we have to be patient. We have to exercise intelligence, how to deal with different technology and coordinate and also strike a right balance between each other. And that's what the standard essential pattern is about. Lumenci handle a lot of those. Next slide, please. All right, so this picture gives you another challenge, the RAM area, radio access network, the RAM area. That's one before the front hall. So you can see on the right-hand side, all the radio access network is monolithic, sometimes proprietary, logged into each vendor, and also not shared by any operator too. And some of the cell tower can be shared among the carrier with operating requirement, but very seldom that will be like the picture on the left-hand side. On the left-hand side, you can see that the radio access network component will be divided into 3 blocks as advertised by the Open RAM organization. It will be modular. It will be allow multi-vendor interaction. We call it MVI. That means what? It will not be proprietary. It will be open so that each company, no matter big or small, if they are technology innovator, they can add value to this open access network. So thereby driving the cost down, and also one important to make it a commodity, makes a commodity, right? Every subscriber, no matter where we are, you can access to the nearby cell tower and get connected. If you allow small company to engage, it will be a lot of exciting technologies such as the AI, ML algorithm, we talk about it. So making this radio access network as modular, as reusable, and as open as the IMS core. Currently, we have 5G network slicing, but this part is still remain closed. We expect Open RAM to have a big effort in pushing it to benefit all the global operators. Next slide, please. All right, go back to you. Babbo, we share with us some of experience with the tier one telecom equipment vendor. Babbo, back to you.
Thanks, Vani. So in Lumenci, we just not work on all the theoretical concepts, but we also help our clients with multiple testings related to the cellular and WLAN, which includes Wi-Fi, Bluetooth, and coexistence network. So we help them with the different campaigns related to patent monetization or licensing. We also conduct so many tests for Lumenci thought leadership activities such as blogs and white papers. So here on the screen, you are seeing some of the snapshots from some of the testing we have performed related to the cellular beamforming as well as the coexistence networking. So what coexistence is, so if there is a single chip that contains 2 radio modules, let's say one is Wi-Fi and Bluetooth, we analyzed what is the behavior and how they coordinate with each other when they are coexistent on the same chip. So we worked on some kind of amazing and interesting test setups, and we are continuing working on that in future also. Over to you, Bunny.
Okay, thank you, Babbo. That is our actual review experience working with the client in accomplishing some of the results we want to achieve. We can go back and try to do another test to verify our concept and also our report. Next slide, please. All right, so in order to cope with all the innovation in emerging technology, we want to share with you Lumenci is well positioned and well equipped to meet the future challenge. You can see this map, TTG, Telecom, Wireless, and also Networking Group is the TTG. We are working very closely or even hand in hand with the other technology group in the company. For example, the software technology group and also the upcoming hardware technology group, we also call it the semiconductor group. We're all working hand in hand together. Let's take example, in the future iPhone 14, we will expect to see new hardware such as A14, A15 chip inside with the latest and greater OLED screen, make the image crispy and sharp for us to view it. For example, viewing high definition 4K or even 8K movie. Those are the hardware and semiconductor part. Don't forget also the 6G antenna. That's a transceiver that we need to understand how it works too. On the other side, if you have new hardware, if you don't have software support, that is also no use, right? There's a lot of software enabler for AR, augmented reality, virtual reality kind of devices. It's rumor Apple's building some of those too. Those are software enabler. Also the latest and greatest mobile operating system, Android and also iOS. We see that happen to support new application on the devices. And the most important is no device, as we try to emphasize, no device will be an island. They all will be connected within your home, within the city, and also within the whole United States or even globally. So we have to take care or understand the underlying technology, 6G or even the latest wireless LAN or even Bluetooth too. So in Lumenci, we have worked hand to hand together in a single client request. All three groups work together to work and resolve the problem that we have. Next slide, please. All right, so it's time to go to our Q&A section. We will let the mic open. We will prepare answer for you if we can able to answer. You can feel free to open your mic, ask us real time or in person, or you can drop a question on the chat box and we will go through that.
Hi, I have a question. So, and thank you for the amazing session. So I would like to know more about how the AI part that we discussed will impact on the standard forming process in 6G.
Okay, that's a very good question. I think we talked about that one in the slide too, but to a more in-depth, AI and also all the machine learning will be a upcoming agenda in release 21 or any 6G standard implementation. Why that's the case is what? The AI software agent will make all the device better connected. If they are better connected, that means what? They need to work in harmony. They need to work in harmony or in sync to deal with the upcoming situation. And I have taken the example of New York City to you already. How does all the driverless car and pedestrian or bicycle work together, or even running loose pet work together, right, to avoid accident like that? So there will be all the things going on. We also need to understand that the high bandwidth upload and download speed also allow things like AI to happen. Those are all the backhaul application running simultaneously, and with the low latency, the predicted event or response action can be undertaken by the devices. I hope that answers your question.
Yes, it does. Thank you.
On our service, I would kindly ask you to go visit us at www.lumenci.com. That will bring us to the end of this webinar. If you want to chat with me or Bubble or anyone in our company, feel free to drop us an email at the address below.